It's finally out. I am finally publishing the video on the ELR battery repair. I guess I should start by saying I apologize for taking this long because some stuff got in the way and I had to prioritize that. I couldn't really put too much time into this video. I guess that's a good thing at the end of the day though, because I've been able to test this car very thoroughly and I've been driving it for roughly 6,000 miles-ish. I haven't really kept very good track of that. But I think it is worth noting that I do not take it easy on this car. I do not take it easy on the battery. I floor it every single day, and even when the battery's dead, I floor it a lot, and to the point where sometimes the engine keeps on running after I come to a stop. And it has been perfect. Zero issues related to the battery. It seems to be balancing in an unexpected way, but it's doing it correctly, so that's good. I think I learned something new there. So I'm pretty happy with that. And I can tell you right now, it is going to be a long video, so absolutely feel free to skip around. I'll try to make chapter markers and everything and cut it down as much as I can, but I expect it to be a long video because I tend to ramble. I just do that. But anyways, what I am talking about is fixing a bad cell on my ELR, actually repairing the pack instead of just replacing it. So for those of you who don't know, which is probably most of you, this car had a bad cell, just one bad cell. The car has 96 cells in its battery pack and only one of them was bad. And I decided that I was going to repair the pack. Instead of replacing the pack or replacing one of the sections, I decided to repair a cell. And I got a lot of people asking me why I was going to do that. Why am I not going to do a full battery replacement, or at least a section replacement? Well, the section, I did consider it, but I can't find them. They just don't exist, apparently. Everyone that I found is listed as degraded, basically, so they're being sold as off-grid storage, like if you have solar or something. They're not really good enough to be used in a car as a replacement. I could go with a new cell, not a new cell. I could go with a whole replacement pack. I could get a used one for like $2,000-$3,000. Then I have to ship it somehow here, which is probably going to be more expensive. But here's the thing. This battery, almost all of it is in really good condition. Even on a scan tool, it shows that the capacity is 40 amp hours, which is exceptional. All the cells are perfectly balanced to each other. It's just one cell that's bad. And even in its bad state right now, I can still get around 30 miles of range on this battery. I can keep going, but if I go too far, the car throws a code and goes into limp mode. That's not fun. Well, it feels like a bit of a waste to take this whole pack and just discard it and replace it with a pack that is probably going to get me 30 miles of range anyways. I would be basically paying for the convenience of not having to put my car in hold mode every time I'm going to go for a long drive. That's not worth it to me. Now, I could go with something like Green Tech Auto. They have a remanufactured battery pack, and they even have what they claim is a new one. Now, I'm not sure how new that is. I'm not sure exactly what that means because these cells are not made anymore. But the new one is 10 grand. This is a nice car. I like this car a lot. I don't like it that much though. For one, it's not in the best condition. It's got some damage on the interior. It's been in three minor accidents. Two of those repairs were not amazingly well done. It's got some scratches on the interior. It's got broken taillight. The seats are worn. So it's a nice car and I enjoy it enough that I am willing to put all the work into it, but I'm not going to put a bunch of money into it because that's money I'm never going to see again. And I really like EVs, and I see myself buying an EV in the next 2 or 3 years. So it just doesn't make any sense for me, financially speaking, to sink $10,000, probably more, into this car. It just doesn't make any sense. There's another reason why I did not go with a replacement pack. I just can't afford that right now. It's just not in my budget. So it just really didn't make any sense. Even if I could afford it, I probably wouldn't have. I would still have done the fix that I did. What I need is a Band-Aid fix, and that is exactly what I'm going to do. So what is my current plan, since I'm not planning on tearing apart the section to replace the bad cell? I still have the batteries, and I believe they will be a good fit. So what I am going to do is I'm going to somehow attach 2 cells. Actually, it's 4 of them in parallel. They are 7.5 amp hours each, so a total of 30 amp hours. I will somehow attach them to the battery. I haven't figured that part out yet. And I'm going to run heavy gauge wire from the add-on cells that I'm putting on to the pack, basically tacking on an extra battery to the already bad cell. This is not ideal, admittedly. It's not the best solution, and I don't plan it to be a long-term solution. But I plan it to be long-term enough that this car will keep on working for me while I get something else. And then I'll figure out something. I figured that this way, worst case scenario, I can reverse what I did if it somehow makes it worse, which I don't expect it to. But even if it does, I can somehow reverse the work I did and at least leave the car to where it is right now. So that's what I'm going to do. I'm going to essentially tack on 4 extra cells to the bad cell that I already have. I have to figure out a way to mount them inside the battery. From what I've seen on some videos, I know where I'm going to mount them. And yeah, the hardest part is probably going to be dropping out the battery and taking it apart. And the easy part is probably going to be making the connection and then just putting everything back in. So the first thing I'm going to do some tests right now. I have with me, I should have with me. Do I have with me? Yes, I do. This thing, this is the Top Done, can you see it? So, you probably can. Top Done, top scan tool. Not a sponsor. I bought this with my own money. And it does have a subscription, which I fucking hate. See, this is the shitty part about products like this. It has an update, but like, this is a 11-year-old car. Nothing has changed, and nothing will change. So why do I need to update? I don't, but it doesn't let me do anything if I don't update. This is why I hate these kinds of products. And this is why I warn people, like, yeah, it might be great and convenient to use, but the fact that it has a subscription means that you're still tied to them. So definitely keep that in mind when you're buying stuff like this. This is something I hate about this thing. I don't need to update it. Nothing has changed in my car. There's no need to update, goddammit. Oh well, whatever. And it does have a subscription, which I fucking hate, but it's been great. This thing is $60, so you basically buy the subscription and you get a free scan tool with it. And this thing allows me to see all the computers in the car, including the hybrid power control modules, the battery energy control module. I can see all the voltage in the car, and more importantly, if the car goes into limp mode, I can use this to clear the code and get me going again. This is fantastic. It is an absolute lifesaver because I can just use it with my phone. I don't have to mess with GDS2 and the VCX Nano and have my laptop with me and figure out how to use it, and I don't have to do any of that. I just use this and an app on my phone and it works fantastic. I'm going to use this. I'm going to test the battery right now and see how the voltage sags when it's under load, and also how the voltage rises, I guess, when it's under regen. So there's an empty stretch of road over here. I can do some 0 to 60 runs. I will do that right now. I'm gonna stop and I'm gonna floor it now. Oh yeah, looking at my screen, it's dropping way more. 22. Go, 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 and hard on the brakes because I'm approaching a turn. All right. Let's go. I wish this car was faster. I'll have to look at the video recording because I don't want to be looking at my screen while I'm going 60 miles per hour down a small road like this. I will just give you the conclusion right now, in case you're curious. So the fix did work. I've been driving this car, I apologize, because my garage is also a mess. But I've been driving this car for roughly 2 months now, 1.5 months. And I drive it between 60 and 100 miles every day. I drive a lot. And the car has been working flawlessly. As you can imagine, there is a lot of battery driving and a lot of hold mode driving. And it has worked flawlessly for all of that. So I am glad to report that this is fixed, at least for the time being, until the next thing breaks. Alright, so I'm getting everything ready for the car. You're gonna need some way to lift the entire car up around 20 inches off the ground. That's the ground clearance you're gonna need to slide the battery out. I got some moving dollies. These were not expensive, they were cheap Harbor Freight ones. Each one's rated for 1,000 pounds, so more than enough. I'm using 6-ton jack stands because that's the only ones I could find that go high enough. This jack is almost a good size. It's just ever so slightly too short. It's like 1 inch too short. So I have some 2x4s around the other side of the car, and I'm gonna hopefully, for those last 2 inches, use something to lift it up. Now the ELR is particularly annoying to jack up because the actual pinch welds or the jack points are, so there's this skirt and it hangs below the jack points. So normally the jack would hit the skirt here, and you can see I've already done some damage here. Had a bit of an incident one time. And these little rubber pucks are just barely enough to get it to lift up. It still contacts the side skirt, but it doesn't damage it at least. It's pretty annoying though. Hello, it is voice over me interrupting. Unfortunately, I guess I lost the video footage of me actually jacking the car up and putting it on the jack stands. But basically, I would go around the side of the car, so I would raise one side up a little bit, put the jack stand under it, then go to the other side, raise that a little bit more, put the jack stand under that, and then go back to the first side, raise it a little bit, raise the jack stand, go back to the other side, go back and forth. I had to do that like 4 times. And then the jack itself was not tall enough to raise the car as high as I needed it to go. It was like 2 inches short, so I simply put a small 2x4 puck, like little piece of 2x4 on top of the jack, and just use that to raise the car that little extra 2 inches that I needed it to go. It was actually 2 pieces of 2x4 and they were screwed together so they wouldn't move around. Yeah, just 2 pieces of 2x4 screwed together between the jack and the car. That gave me the extra height I needed. And obviously you gotta make sure, you gotta be very safe. You have to be very careful, go very slowly as you're doing something like this. If you have something like ramps or like that quick jack system, definitely use that because that would be a safer and much easier solution. And of course, if you have a 2-post lift, then you're golden. That was not fun. So I have the car raised up, and apparently you need, at least from what I've heard from Volt owners, you need at least 20 inches between the bottom of the car and the floor. I like these because they're kind of recessed, so they kind of capture the jack stand on these sides. And then on the back, god dang, that's not what I want to do. Sorry about that. There's these holes, so I have part of the jack stand in that hole. Now, to raise up the car, so these jack stands raised to like 23 inches. That was just barely enough on the back. The front is fine. I think there's actually like 1 or 2 detents left. I had to raise the car up from here, and my jack, all the way back there, only raises to 19 3/4 of an inch, so I had to put some 2x4s in here to give me that extra last 2 inches. After that, the whole car, this whole bottom here is exactly 20 inches off the ground. So if I need more clearance, I think I can remove it. And this is like probably an extra 1.5 inches. So I think I should be good. In case of the ELR, you can see that the side skirts, they actually hang quite a bit below the pinch welds. You can see mine are kind of messed up. So I think I might end up removing these just to give me a little bit of clearance. We'll see once I remove the battery how that goes. There's another video floating around of a Volt owner doing this. So there's a couple of grounding straps and heat shields surrounding the battery. There's one in front of the exhaust. That's what I'm working on right now. And there's just a bunch of bolts. And so that's what I'm gonna work on next. All right, so for this heat shield, that's the back of the car. And obviously this is the driver's side. These, you just take needle nose pliers and just spin them off. A little bit tight, not too bad. And then there are these grounding straps, so just remove these. So these grounding straps were 10 millimeters, and they actually, kind of get stuck. These holes kind of bite onto the stud. Now I pried it off, but you have to be careful because the stud itself has a lip. So at first I was sticking a screwdriver and prying the actual stud. You have to be careful to not get under the stud like this, but just under the connector, which sits here. So just word of caution right there. Also, these are quite rusty on my car. These were fine. And I just snapped that one. So there's a fourth one here I didn't see, first of all. you should probably be a little bit more careful than I was when removing them because they might be rusty. So probably just work that nut back and forth a little bit. All right, so again for reference, that way is the front of the car. These are all the connectors for the battery. Have the coolant here. I have no idea how these come out, so I'll have to figure that out. Bunch of communication data wires, and of course the orange ones are the spicy ones. For those nuts holding on the heat shield, in general, I try to thread them back on any nuts or bolts I removed, just so I don't lose them. I don't have to keep track of them. I know that they're here. This is where they go. All right, this is gonna be fun. By the way, I guess I should have also mentioned it. The 12-volt battery in the back, I disconnected it first, and then on the ELR in the center console, right behind it, there's a panel. It just pulls out. It's clipped in place, pretty stiff, and there's an orange connector. I can show that to you in a bit. So this is the guy you have to remove. So it goes in here, and there's actually instructions on the side. Very helpful on how to remove it. But there's basically a little button. You kind of push it, and then it kind of half releases, and then you push it again, and then it releases completely. So it first goes here, so you press it in, and it kind of half releases, and it's going to be captured over here. So then you press it again, and then you fully pull it out. I don't know if there's a specific order, if you have to disconnect the 12-volt battery in the back first and then this, or vice versa. I disconnected the 12-volt first. Hopefully it doesn't cause any issues. Also, I suggest you open up your glove box and open up the doors and trip the latch over here. So just with your finger, move it in. That way, you can't accidentally close the doors, because without power, you can't open them. Right, this is the part I'm not really looking forward to, and that's all the connections under the first heat shield, front of the car that way. So these two connectors are easy, just pull them out, just like any other connector. So this big old connector here is the main one, and that's held in by a 10mm apparently. I can't even see it, if I'm being honest. And then there's two more connectors up top, which are apparently more traditional. Then you've got the coolant over here. I can see a little clip actually, so what I'm going to do is I'm going to pry it out and pull these out. And I have a bucket with me. Where it is? There it is. And drain the coolant there. And I have to go buy some coolant because I didn't, and I will almost definitely need it. Oh well. Alright, the car is now relieving itself into this bucket. So after prying, whoa, whoa, Jesus Christ, that just started spewing out of nowhere. Ah, I got it all over my face. That was fun. Anyways, as I was about to show before I got rudely interrupted, you pull those clips out and you have to pry these out. I just use a screwdriver. They are hard lines, surprisingly, and so they're a little bit hard to pry out. But once you pry them out, they start spewing coolant at unpredictable rates, it seems. Also, make sure you save the little clips. Very important. You don't want to lose them. Make sure that you keep them safe. Alright, I might be ready to start dropping the battery. So you can see I have a piece of 2x4. They're actually two pieces screwed together closer to the front of the battery, and I undid the screws most of the way. It's the big ones you see here that are undone. I kept them in case the battery decides to drop or something. The ones on the back are also slightly loose. These back ones here are 13 and the rest are a 15mm. I also undid all the connections there and waited for it to all drain out. The top two connections, the top orange ones, so the cable itself, like the connector itself, has a smaller connector at the bottom. That one has to be removed first before the big one comes off. And then the biggest one is just a 10mm, so you unscrew it, and then as it starts backing out, it kind of comes out. I had to pry the lines out. They were really hard to pry out for some reason. Alright, so what I'm going to do, I lowered it a bit and the battery is indeed moving. So I got all the screws out, so I'm going to probably remove the two front screws all the way. Probably going to raise it up a little bit before I do that. And slowly lower the battery, and as I do so, start removing these screws here. And tilt it forwards, basically, until I can rest it on one of the moving dollies. And then after that, I'll do the same thing on the back, slowly lower it until I can rest it on another dolly. The center of the battery, I'm pretty sure it's right here where these two little cross beams go, is pretty weak because there's nothing supporting it there. And it's got a cutout, like a valley, so it can bend there. So I'm being careful with that as well. Probably going to film this and speed it up as I lower the battery, because I haven't seen any videos of people lowering the battery itself. They just kind of show before and after, but they don't actually show the process. I will show mine. It's probably not the best process, but Hopefully it's what's gonna work for me. Okay, so my original plan for the battery was to basically lower it slowly. So I was going to put a jack in the front, a jack in the back, and lower it little by little. And I started lowering the front because the only other jack I have was a little bit short. However, I would later find out that you can actually get away with lowering the battery with just a single jack and the 2x4s. So notice where I placed the black bigger jack. Close to there is actually the center of gravity of the battery. So if you place the jack there, you can balance the entire pack on just one jack. I just kind of find that out by accident. I still had the red jack in the front, so I used that to lower the battery slowly, but I would later find out that I didn't need to do that. And at this point, I'm transferring the battery onto some dollies, so I put some 2x4s on the dollies to remove the one that's under the jacks. Then I jack up the battery without the 2x4, and then I lower it back onto the dollies. Well, here it is. Glorious, isn't it? So this car is exactly 20 inches above the ground from this panel right here. That was just barely enough to get it through on the outside of the car, through the underside of the car. This was just barely touching on the skirt, so I just pushed it up with my hand and just forced the battery out, and it seems to have worked fine. So next thing is remove a bunch of bolts and lift this plastic panel off. I'm surprised to see it is black like this, because all the other Volt batteries I've seen online they're like a silver, like aluminum looking casing, except for the Gen 2 Volt batteries, which as far as I remember, they are black like this. I don't think this is a Gen 2 Volt battery, but I don't think it came out of the factory like this either. I'm not sure what's going on here. Alright, and here it is, with its top removed. This battery is slightly different from the ones I've seen online. My guess is that because this is a newer battery, it's probably around the same batteries you'd find in a 2013 to 2015 Volt. They've done some changes, like the outer casing that is black. Also, the videos I've seen, I'm pretty sure these are like copper bus bars, but here they're just cables, just copper cables. The batteries, I am probably going to mount them here somehow. I still haven't figured that out. I'm probably going to 3D print something to hold them here. I need to figure out how much space I have. I believe they will be able to fit. So these are the cells I'm going to be using. They come, set that there. So this was originally a 3S 2P pack, and I split them apart. I split the individual series connections, so I still have these cells that are joined in parallel. And I was planning, I might even be able to join them, or to put them here like this. Probably more like this. I'll have to figure something out. I believe this will fit because it's actually still lower, or at the very least at the same level as this. And this bottom part here, or I guess the top half, it is taller on this middle section to accommodate this. So I believe I can set them here like that. The only thing I'm really not thrilled about is that these are not going to be cooled or heated by the battery's own thermal management system. My first idea was actually to put them here in the valley. I don't want to touch anything right now, but to put them here, somewhere here. My hope was that hopefully enough heating or cooling would make it through the cells to this black plate here to somewhat cool or heat these batteries as needed. But I don't think there really isn't a lot of space to mount these cells here. And even if I could like bend these bus bars to make this fit, I don't think it would fit, because there's a valley here for a structural piece that's in the car. So I don't think that's a good idea. I think over here is going to be my best bet. And obviously, this should go without saying, this thing has really high voltage, almost 400 volts. This can absolutely kill you. So please don't try this if you're not confident what you're doing. And please be careful if you do try this. Alright, so at this point I am charging the bad cell. I want to test the bad cell and test against a good cell. It's charging right now. I'll test this. I'll charge another good one and discharge them, see how much capacity I get, a good one versus a bad one, and what the internal resistance is. As for how I'm going to connect the new cell to the old one, I have a bunch of wire that I got for free from work. This is just scrap, so I have this 4 gauge. At first, I thought, no, give me the thickest wire possible. So I got this. This is 0 gauge wire, but about 5 seconds after they gave it to me, I realized this is way too thick and I have no easy way to connect this. So I went back into their scrap wire pile and dug up these 8 gauge wires. Now, at first I was concerned, what if this doesn't have enough capacity in amps? But after thinking about it, also after looking at this battery, I'm not that concerned for 2 main reasons. The first one is, yes, this battery can deliver up to 130 kilowatts, but that's only for very short periods of time. It's very short bursts. I believe it's only officially rated for 10 seconds, I believe. And either way, even if it was rated for that continuously, you never see that because when you're driving, you usually accelerate and then you're just cruising. So at least that's the way I drive, and I'm sure that's the way most people drive. I'm not taking this thing to a racetrack. So this wire is not going to see a lot of current for very long periods of time. It's going to be very brief periods of time. Also, because I'm basically piggybacking off of an existing cell, that's going to lower the current even further down. So I expect this wire to see at most 30 amps continuously, with peaks in the maybe 100 amps. And that still worried me, so I just decided I'm going to double up. So I'm going to have two of these wires for the positive and 2 of these for the negative. So that should be, I feel that should be plenty. Also, looking at this battery, I'm not sure what gauge this is. I haven't checked or anything, but it doesn't look significantly thicker than what's here. Obviously, I don't know what's under that insulation, but after looking at it, I think I'm going to be fine with 2 short runs of 8 gauge. Plus, it's going to be like, what, 3 inches of wire anyways? It's a very short run. I don't think it'll be a problem. It is the next day, and I charged the bad cell, which is the one that I am testing right now, and then the cell next to it, which is this one, to around 4.15 volts, which is higher than the car will usually charge them to. The car usually keeps them at 4 volts when they are full, at least on my particular car. That's what I've observed. And I'm testing it down, and so I had to set to 3 volts, but because of voltage drop, it's going to really cut off when the battery's at like 3.4 volts, which will be any time now. And the bad cell is getting 34 amp hours, roughly, and it has an internal resistance of 15 milliohms, according to this thing. When I first started the test, it read 12, and it makes sense as the battery's discharged, their internal resistance goes up, so that makes sense. Curious to see what the what the good cells are going to show. Yep, there it goes. It just finished test, so 34 amp hours, 116 watt hours from a single, well, it's not a single cell, from 3.7 volt cells. It's pretty decent. So this cell could be used, if I were to extract it, or if all this whole battery was in the same condition, it could be used for like off-grid storage still. But again, it's not good enough for the car. Let's test the new one. Oh, let me check the voltage it's at, because I was checking the voltage under load. So the voltage right now is 3.36. That's pretty much about where I want it to be. Oh, and for those curious, I am testing at 30 amps, or at least I'm telling the thing to test at 30 amps. It can't draw that much at this low voltage. That's as much as it can get, 26 amps, roughly. So this one should take, probably in theory, closer to 2 hours if the car's estimate of 40 amp hours is correct. So let's see. This one is 11 milliohms. It's not that big of a difference, actually. We'll see when it goes down how the resistance changes as the battery gets discharged. Alright, so the test on the good cell is done. And I gotta admit, I'm really surprised. So I just checked with the voltmeter, and it's at 3.4 volts and 37 amp hours. So really not that different from the bad one. I'm kind of shocked, actually. I expected them to be either way higher or the bad one to be way lower. I guess they're not. So with this in mind, I am reconsidering using such a big cell. Alright, so now I'm in my room. After seeing those results from the battery test, I decided to use just one of these cells. So I basically cut these apart, because they are together. They were soldered together. I've cut these apart, and basically the cell will go right here. And I have this case that I've modeled. So this piece over here, this is where the cell's going to sit. It's basically like a little cradle. And then this one, which is what I am printing right now on my 3D printer, is like a little riser, which sits here because the cell is going to overhang this part right here. It sits like this. And I don't want that floating out there like that. Even though it's going to be in a little case, this bottom part is only 1 millimeter thick. So that thing is going to sit here and basically make this one level piece all the way out until here. And then these holes over here that I molded, or modeled, I mean, it's a little hard to do one-handed. Basically I'm going to make a cap that fits, it basically clips into those holes to cover up the connections. It's going to be basically like this, so I can spread it open, set it down, and then it'll pinch down and lock in with those holes. Alright, and then there's this lid. These are just prototypes, that's why this one's broken. I just printed it really quickly. But this lid has these little features here that slot into these guys here. So this goes like this. Alright, so these are the final finished parts. This is the lower tray. This goes over here. It's a little bit thicker to hopefully keep the battery from warping, because this isn't perfectly flat out here. And then this is the upper half. I just cut these little holes here for the cables. I didn't model them in because I'm lazy. And the cell, it sits upside down. I would have liked it to sit over here like this, but just because of the way these little like flappy parts are. But because of the polarity, I have to sit it like this, which isn't a big deal. It still sits in there very nicely. And this, yes, this goes like this. I'm not going to clamp it down just yet. Forgive me, I'm doing this one-handed. So this would snap shut, and I have the connections here, but it's going to be mostly protected. And then the wires are just big enough to fit in those holes, so they'll be pretty well closed off, this bare connection. Pretty happy with how this turned out. And I have the pedestal there, which I just printed, and looks like it didn't turn out very nice, but I don't care. Right, it is several hours later, and that was very much not fun. The problem is, even this 40-watt iron is not nearly hot enough. Well, that's the first problem. It's not nearly hot enough to get the solder to melt onto these things. There's just way too much metal here. The second problem is, this would have conducted a bunch of heat into the battery. So after trying a little bit, I gave up on the solder. It's just not a good idea. I was barely able to get the solder off of the smaller cells that I'm attaching here. So there's no way I'm going to get it here. So how did I do this? Well, I found in my stash of junk these two copper lugs, and I have crimped the cables on here as best as I can, and they are nice and tight. Both of them. Good. Now, the challenge was attaching these. So, over here, I drilled a hole, and I accidentally shorted out the drill bit, and it immediately started glowing red hot. I really do mean immediately. Within half a second, it was glowing red hot, and it was broken. So it was broken off in here, but at least I had a hole. Then I found the shortest machine screws I have, stacked some washers on here to basically stop the thread from sticking out, because I can't find my Dremel cutoff discs, and I need to get this finished ASAP. So I just stacked some washers over here to space this off. There's a washer here and a nut, and they are clamped together. For this part, I tried drilling, and again, I shorted something out despite me adding the tape. And again, I broke a drill bit. So I instead took, and this was incredibly fun, as you can imagine, one of these. I have self-tappers, but again, I can't find them because I moved recently. So I just found these in my stash, just machine screws. And I started by hand trying to screw it in, and until eventually I got a hole. Then I screwed it out and did the same thing here. So there's some washers, the copper lug, and then a nut back here. It's not pretty, but it works. So that's all I'm asking for. Right. Let's finish this and hopefully see if I can put this battery in the car today. I don't think I can because it's already 1 a.m. and I have to work tomorrow. But we'll see. Okay, so looking at this, I know a lot of people are going to be questioning this method of connection that I have. And I also didn't explain everything very well in the video. So my original plan was to actually solder the 8 gauge cables onto the high voltage pack. Unfortunately, my soldering iron is not powerful enough for that. It couldn't get hot enough, and so I couldn't make a connection. I was also just dumping a bunch of heat into the cells, which I didn't really want to do. So the next best bet was a mechanical connection, which is actually better. Solder is brittle, it can crack, so it's not really the best solution for this case. Now, one thing I would have liked to do differently is to use a better screw. This is just like a random machine screw I have. I would have liked to use something that was shorter. Unfortunately, when I was doing this, it was like 2 a.m. by this point, and also I needed the car the next day, so I had to finish it that day. And obviously there's nothing open. I can't go buy new machine screws. I couldn't find the old ones I had. But looking back on it, I've had the last 2 months or so to think back on this. I don't think there's anything that I would have done differently today other than just the screws. I can't really think of any better method to secure these cables. Now, I know a lot of people are going to be asking about drilling into these little tabs where the connections are made and potentially increasing their resistance and making them get hot. I'm not really concerned about that because if you think about it, this is a metal screw and bolt, or yeah, metal screw and nut, I mean, clamping this together. They're conductive, so if electricity has to, it will flow through it, and I don't really think that high resistance is much of a concern here. The same thing goes for my decision to use just a single run of 8 gauge up to the auxiliary cell. If you notice those orange wires closer to the bottom, they look very similar in thickness to the 8 gauge wire, and there's only 2 of them for the entire pack. Also, the mid-pack disconnect, again, it's just a single run of wire, and it doesn't look that much thicker than the 8 gauge I'm running. And keep in mind that because I'm using a smaller auxiliary cell, it's only 7.5 amp hours, they'll be contributing less current to, compared to the rest of the overall pack. So I don't expect this to be pulling more than maybe 100, 110 amps through those 8 gauge wires peak, and continuous maybe 15, 20, maybe 30. So I think it'll be fine. All right, so I got the cover back on, and I've already stuck this one down, and my adhesive is going to be high strength hot glue. This stuff is ridiculously strong. It seems kind of janky, but I've used this a lot in a lot of other projects with excellent success, so I will use it here. Besides, it's holding a single cell. It's not like it's holding the whole car together. I have sanded the surface here and under here where it attaches, and I have used IPA to clean it. That's why it looks different. It's all scuffed up now, so the glue will have a better better adhesion. Can you tell I'm tired? All right, I got the battery all connected. Now I'm ready to put this little lid on, which will go like this, and this will be done. Whoa, hang on. I thought you said you weren't going to solder anything and that you were glad about it. Well, yes, but also these cells already came soldered, so they already had solder on them. I didn't really have much of a choice here, and even if they didn't, I, again, can't think of any other ways to connect to them. And I also want to mention, I don't really believe as strongly as some people do that you cannot solder to batteries ever or they will explode and you will start nuclear warfare. Yes, it is true that it will dump heat into the battery, and I do agree that it is best practice not to solder to a battery if it can be avoided, but I've also encountered many, many OEM batteries that are soldered together, and they work just fine. I've also soldered batteries myself, and they've also worked just fine. If you do it correctly, if you know what you're doing, it can be done without damaging the battery. So again, I'm not really concerned here. Would I have preferred a different method? Yes. Did I really have much of a choice? Not really. Right, here's everything all buttoned up. Got the cover in, got this part in, got this little wiring harness that I did end up removing back in. All the connections are done, and I'm ready to put this thing back on. Now it's the part I'm dreading, putting this back up there. In case you wanted to see what this looks like without the battery, there's the gas tank. It's really small, actually, or at least it looks pretty small. It's 9 gallons, though. I guess it is pretty small. There's that brace. Apparently, early Volts didn't have that in the middle of the pack, even though they do have the Valley. So that had to be added. I believe it's part of the recall, actually. It's for structural support. There's some sort of adhesive there. Actually, haven't seen that before. That's interesting. Okay. And then the interior is right through that hole. And then there's all this stuff in the front. And yes, I am upside down. I apologize. So it's been 2 days, and I actually had to drop the battery again because when I charged it, I didn't really charge it very carefully. So the cells that I tested and charged, they were really out of balance, and I expected the car to balance it on its own, but it didn't. I don't know if I have to drive it a certain amount to trigger it, or if I just didn't wait long enough. I left the car plugged in for like 12 hours straight twice and discharged it multiple times, but it still wouldn't balance. So I had to drop the pack and manually balance the cells. So I put the pack back in. I've connected everything, which is essentially doing what you did to remove it in reverse. Now, the next thing, because you will lose coolant, you need to fill up the coolant, and you want to use DexCool and DexCool only. In this case, I just got premix because it's easy and I am lazy. And well, I don't know if it matters. This one says it's hybrid and EV ready. Apparently this stuff has to be, or at least I've heard, I don't know how true this is, it has to be deionized, which this is. Otherwise you lose pack isolation. I'm not sure how true that is because the coolant is contained, but I'd rather not risk it. Also, this stuff is known to gel if you mix it with something else, so please, please, please do not use something else. Use DexCool. They don't call it DexCool for nothing. So my top scan has a coolant pump bleed procedure, which you might be able to hear right now. So what it does is it starts the pump. At first it starts it really, really slowly. So you fill this up with coolant and it starts really slowly, and almost all of it will be gurgled down, and you just keep on filling it up, and it starts running the pump, and it starts actuating some sort of valve, and you can hear water sloshing around. Even after doing this procedure, I would still kind of hear water sloshing around for the first day. When I had the car plugged in and I heard the pump run, it would go like it's doing right now. But after driving the car a little bit and just keeping an eye on the coolant level, it stopped. So I expect it to do the same thing. It might be a good idea to keep one of these in your car just for like a week or so and just check the coolant. So in case you've never tried to fill this one up, it does have this anti-tamper bracket to lock you out from filling it up. You just take your hand and just lift it out of the way, and you can remove the coolant cap. That's everything. Apparently this coolant bleed procedure takes about 30 minutes, and I think technically you are supposed to like vacuum bleed it or use some sort of special equipment. I don't have that. I didn't have any issues the first time I did this, and as I said, after the first day, all the water whooshing noises were gone, and I did notice the coolant drop a little bit. When I finished the previous day, it was here, and afterwards it went down here. So probably just keep an eye on this, let it do its thing. Also, before I put the pack in, after I put the pack in, I did not put the heat shield that goes over here back on, just because I want to check for leaks while this is running. Also, you can really hear water gurgling here.